So, dear friends, in this video we are going to discuss about important formula required for calculating velocity, mass flow rate, critical pressure ratio, and other related uh, formula related with thermoengineering subject 2, unit 1. So, the expression for exit velocity of the nozzle based on steady flow energy equation. As we have come across steady flow energy equation for various thermodynamic components like boilers, nozzles, turbines, compressor, condenser. For nozzle also we have steady flow energy equation. There we will be coming across kinetic energy alone. There will not be any heat energy. So we will be having kinetic energy, no potential energy. In the case of nozzles. So if you look at this, we can easily understand from the enthalpy entropy diagram that P1 and P2 represents the pressure at inlet and exit and velocity at inlet and this is called 1 and 2. So C1 is the velocity at the entrance of the nozzle, C2 is the exit velocity, H1 enthalpy at entrance, H2 enthalpy at exit, initial pressure at initial and initial pressure at exit. Similarly, specific volume, cross-section area of the nozzle and mass flow rate through the nozzle in kilogram per second. So when we come back to the steady flow energy equation, this is a standard format. H1 plus C1 square by 2 plus GZ1 plus dq by mass flow rate equal to at the exit side. No heat is transferred during the flow through the nozzle, as I have told in the beginning. No heat transfer in the nozzle. No work done is doing flow through the nozzle. So we can omit dq and dw. So we will be having h1 plus c1 square by 2 plus gz1 equal to h2 plus c2 square by 2 plus gz2. Here the potential energy, that is a datum line, is also equal. Z1 is equal to Z2. No change in elevation between inlet and exit. If you draw the axis, horizontal axis, Z1 is equal to Z2. So we are going to omit potential energy also. So we will be having H1 plus C1 square by 2 equal to H2 plus C2 square by 2. Steam enters in nozzle with a high pressure and negligible velocity. The C1 is equal to 0. The purpose of nozzle is to increase the velocity at the exit. When the increase in velocity happens at the exit of the nozzle, it is obvious that the pressure will be reduced. So by modified steady flow energy equation, we are having H1 plus C1 square by 2 equal to H2 plus C2 square by 2. So by simplifying, we will be having C2 square minus C1 square equal to 2 into H1 minus H2. So by looking at this equation, we want C2 square, C2, that is exit velocity. We are going to find out exit velocity. So if you take the C1 square to the right hand side, it will become C2 square equal to C1 square plus 2 into H1 minus H2. So if you want to take the square root, that is we want C2 alone. So by taking the square root, C2 will become square root of C1 square plus 2 into HD, that is heat drop. H1 minus H2 can be called as HD, suffix D. Steam leaves the nozzle with high velocity and low pressure. C1 is very less compared to C2. So we can omit C1 unless it is given, unless it is specified. We can comfortably delete the term C1. So C2 will become root of 2 into H1 minus H2. When the magnitude of enthalpies of steam is used in kilojoules per kg, in steam tables, if you take the values of enthalpy from the steam tables or molar chart, the values are given in kilojoules per kg. Enthalpy values are given in kilojoules per kg. So we can find out, we can use the formula C2 equal to 2 multiplied by 1000. 1000, why we are multiplying by 1000 means since we have the terms enthalpy in kilojoule per kg. So to convert into joules, we are multiplying by 2000. So 2000 into H1 minus H2. So finally 2000, if you take the root of 2000, it is nothing but 44.72. So C2 equal to 44.72 multiplied by root of HD, H1 minus H2, that is enthalpy drop from the entrance to exit. In actual, there is also a certain amount of friction present between the steam and the nozzle surface. It is known that friction is there between the nozzle surfaces. This may reduce the velocity by 10 to 15%. So they will give the nozzle efficiency as 0.9, 85% or 90%. So what we have to do is, while calculating, considering the friction of nozzle, the exit velocity will become 44.72 square root of nozzle efficiency into H1 minus H2. So this will be the final equation as far as exit velocity is concerned. For mass flow rate, we have the standard formula continuity equation, m equal to AC by small v. A, capital A is the cross-section area of the nozzle meter square. Capital C is equal to velocity, steam velocity. Small v is nothing but specific volume in meter cube per kg. This is called mass flow rate, m equal to AC by small v. Process, what are the process involved in the nozzle is PV power n equal to constant, that is polytropic process. PV power n equal to constant, n varies. If it is a dry saturated, n equal to 1.135. If it is initially superheated, 1.3. If it is wet, 1.035 plus 0.1 x. Likewise, we can calculate PV n value. So by bringing that PV power n equal to constant, we can modify the CT equation into like 2n by n minus 1 P1 V1 within the bracket 1 minus P2 by P1 power n minus 1 by n. This is in terms of P2 by P1. P2 by P1 is given, n also will be given. So we can easily find out C2. If enthalpy, without using the enthalpy term, we can find out exit velocity of the steam nozzle. This is another formula to calculate steam exit steam velocity at exit of the nozzle. Critical pressure ratio, this is another important concept. P2 by P1 equal to 2 by n plus 1 power n by n minus 1. This formula everyone should remember to calculate critical pressure ratio. For saturated steam, for this is a formula for saturated steam 0.577. For superheated steam, it is 0.546. By substituting the n value, I am saying by substituting the n value. For gases and air, n equal to 1.4, gamma equal to 1.4 for gases and air. For that, the critical pressure ratio is 0.528. So these are the values we got to remember. Expression for velocity of steam at exit, maximum velocity. To find out the maximum velocity, the formula we have to use is C max equal to square root of 2n by n plus 1 P1 V1. This is the maximum velocity or critical velocity. P2 by P1 equal to 2 by n plus 1 power n minus n by n minus 1. The mass flow rate, yes, the same formula is given here. So with those equations, we can easily solve the problems related with exit velocity, mass flow rate. Thank you for watching this video. Thank you.